Today we're going to be talking about finding parallel and perpendicular lines. So in particular, two lines are parallel if they never touch. That means that they will have the same slope but entirely different points. Absolutely everywhere. No points will be the same, and in particular the y-intercept will not be the same. So for example, in the pictured graph, both of these have a slope of 2, but they have different y-intercepts, so as they're going up 2 over 1, up 2 over 1, but starting from different places, they're never going to touch. So how do you write the equation of a parallel line? Well, you want to identify the slope of the line in question that you're wanting to be parallel to. You're going to use the exact same slope, and then you want to either write it in point slope form or slope intercept form, and then maybe simplify accordingly according to what you want. Usually point slope form is actually going to be easier to use. So for example, if you want equation to the line parallel to y equals 3x plus 5, well, the slope of the original is 3, so the slope of the parallel line, I don't know how to spell even when it's right in front of me, do I? Parallel will also be 3. And then if you want to plug directly into point slope form, that would look like y minus y1 would become plus 13, since negative 13 is the y-coordinate, minus negative becomes adding a positive, equals 3, the slope, x, and then that would be plus 3 since you're minusing a negative 3. And then if you really want to write it in slope-intercept form, you would then distribute the 3 to both of those terms. 3x plus 9, drop down the y plus 13. Then you would want to subtract 13 from both sides to undo adding 13. And you would have y equals 3x minus 4. Either way you want to graph it should be the same result. So you would want to start at negative 3 comma negative 13, but that's way down here off the page. So just because of the way that this graph has been physically set up, it's going to be easier for us to go ahead and graph this from point slope-intercept form. So start at negative 4, and then you're moving up 1, 2, 3 over 1 in the positive direction, up 1, 2, 3 over 1 in the positive direction to give you your nice, beautiful line. And then just to help you visualize, the original line would end up looking like starting at 5 and then going up 1, 2, 3 over 1 in the positive direction, down 1, 2, 3 over 1 in the negative direction, and these lines will physically never touch in either direction going on forever because they have the same slope, but they have different points stemming from the fact they have different intercepts but also different points everywhere else. Perpendicular lines is a similar concept, but it's going to be a little bit more work to come up with your new slope. Because perpendicular lines, those happen when two lines meet at a nice, beautiful right angle. How do you get a nice, beautiful right angle? Well, if on the original line, the way you move between points is to go up 1 over 3, up 1 over 3 in the negative direction. The way that you're going to make a perpendicular slope is to, instead of doing that, you're going to go up 1, 2, 3 over 1, in the negative direction. Although here there was a different point for this to cross, right? So up 1, 2, 3 over 1 in the positive direction. Sorry. Let me rephrase. The original one was a negative slope, so we were moving up 1 over 3, up 1 over 3, etc., in the negative direction. The new one, we're wanting to move up 3 over 1, up 3 over 1, up 3 over 1 in the positive direction. A little bit of word salad there for a minute there. Apologies for that. But the key is you basically need to move opposite directions. So the opposite of going up and then over 3 would instead be going up 3 over 1 in the opposite direction. Then that will make a nice, beautiful right angle. So in short, you need to do the negative reciprocal. What does that mean you need to do? You need to flip the fraction and flip the sign. You do a double flip situation, and it's worth physically graphing them to make sure they're making nice, beautiful right angles as well. So let's go ahead and practice this. So here on this equation, on the original line, the original slope was -4. So your perpendicular slope is that you have to flip the fraction. So right now he's a 4/1. You got to put down 1/4 and flip the sign. Right now he's negative. Now he's going to be positive. So that's called the opposite reciprocal. The reciprocal part coming from flipping the fraction, the opposite part coming from flipping the sign. And then you need to pass through the point 8, 3. So if you're going to write that in point slope form, you do y minus the y coordinate is 3 equals the slope 1/4 x minus the x coordinate is 8. You then can also rewrite him in slope-intercept form if you are so inclined. So you would distribute 1/4 times x is 1/4 x. 1/4 times -8 is going to get us -2. And then as our last step to get y by itself, you're going to add 3 to both sides to get y is equal to 1/4 x plus 1. Either way you want to graph it, you can either start at the point 8, 3, and then you can move according to the slope, up 1 over 1, 2, 3, 4, down 1, left 1, 2, 3, 4, down 1, left 1, 2, 3, 4, and oh my gosh, that also gave us that same y-intercept we were predicting. And then you can go ahead and connect it. It might be worth double checking this looks physically perpendicular to the original. The original starts at 4, and it goes down 1, 2, 3, 4 over 1 in the negative direction. Down 1, 2, 3, 4 over 1 in the negative direction. And if you do plot those, not a perfect artist, but that does look like approximately a right angle, so we know we did it correctly. Go ahead and try these next 3 practice problems yourself by pausing the video and then comparing with what we get. So if you want to write an equation perpendicular to this line, again, you need to identify the original slope of this line, which is -2/3. So if the original slope is that way, then the perpendicular slope, this is another sign for perpendicular, is going to be 3/2. Why is that? 3/2 is the opposite reciprocal. So you need to make sure to flip the fraction. So 2/3 becomes 3/2 and flip the sign. The negative becomes a positive. And then you can go ahead and plug this point into point slope form. So you would have y minus y1. y1 in this case is 0, so I'm actually not even going to write it, equals your slope x minus x1 minus a -6 becomes adding a +6. If you really want to rewrite this in slope-intercept form instead, you would then distribute the 3/2. You would get y equals 3/2 x plus, and then I'm going to do off to the side, 6 times 3/2. 6 is secretly over 1. 6 times 3 gives us 18. 1 times 2 gives us 2. 18 divided by 2 gives us 9 is the number that would be adding. Both of these are equivalent equations, but those would be your line that's perpendicular to that. If you want to write a line that's perpendicular to this guy, well, first we're going to have to rearrange this guy so that it looks like y equals mx plus b form, looks like our slope-intercept form, so that we can identify the intercept. So in particular, if our goal is to get y by itself, first I've got to move the x's to the other side. So I'm going to undo adding 2x by subtracting 2x on both sides. 2x minus 2x makes 0. I'm left with 3y is equal to -2x plus 6. Then as a last step, I'm going to want to divide by 3, divide by 3, divide by 3. So then I'm going to get y is equal to -2/3 x plus 2. This means that my original slope is actually also -2/3 this time, which means our perpendicular slope, opposite reciprocal, is going to be +3/2. And we want to go through the point 0, -2, which is a y-intercept anyway. So that means we want to go through y equals 3 halves x, 3 halves being the slope, minus 2, our beautiful y-intercept. For this next one, we want to go to a parallel line to this, but that means we still have to know what the slope is. So in order to figure out the slope, we again still need to get y by itself. So I'm going to move x to the other side of the equation. I'm going to undo adding 7x by subtracting 7x on both sides. And then I get 8y is equal to negative 7x minus 24. Then as a last step, I'm going to have to divide each and every term by 8. So then I get y is equal to negative 7/8. Negative 24 divided by 8 gets us negative 3. So in this case, the original slope is going to be negative 7/8. This means that our perpendicular slope, flip the fraction and flip the sign for the opposite reciprocal, becomes positive 8/7. And then I would recommend, since this is a bit more of a random point, just go ahead and write this in point slope form. So you would have y minus y1, minusing a negative 5 becomes adding a positive 5, equals our slope, 8/7 times x minus x1, in this case 4. And this actually looks messy enough to distribute out that I'm just going to leave him as is. For this last one, we want to find the slope of a line passing through these points, and then find the slope of the line that's perpendicular to it. So let's go ahead and do that. So the original slope, we're going to have to actually solve for this time. So we're going to have to do change in y, so that's 1 minus negative 5 over change in x, 0 minus 6, so that's our y2 minus y1 over x2 minus x1, to give us positive 6 over negative 6, which becomes negative 1. That means for the perpendicular slope, flip the fraction and flip the sign, find the opposite reciprocal. Well, negative 1 is secretly over 1 right now, so that becomes 1 over 1. This is a very rare case where negative 1 over 1 becoming 1 over negative 1 is actually the same number. It doesn't usually work out that way. But then we also need to flip the sign, so that will become a positive 1. So the perpendicular slope of the line through these 2 points would just be positive 1. So to recap, if it's a parallel line, you use the same slope. You might have to find that slope. And if it's a perpendicular line, you want to be using the opposite reciprocal of that slope. So just to really emphasize, if, for example, the original slope was 2, that would make the opposite reciprocal slope negative 1/2. If the original slope was negative 1/3, that would make the opposite reciprocal slope 3. So every time you're looking for that perpendicular slope, flip the fraction and flip the sign. Otherwise, put together all those previous pieces of knowledge that you have from the previous sections on how to write equations of lines through particular points that have particular slopes, and you should be good to go.